and welcome to our single family new construction cost effectiveness analysis update webinar. I think our team needs to work on our titles. That was very long, descriptive, but long. Welcome to the webinar. My name is Misty Bruce Harry, and I'm the coordinator for the Utilities Statewide Program, Reach Codes Program. And I'm here with Aaliyah German from Frontier Energy. Aaliyah is our residential expert in modeling and codes. And we will be talking today about the results of the update to our single family new construction study. I'm going to, excuse me, sorry about that. I'm going to start with a brief introduction and then give you a little bit of background, and then I'll turn things over to Aaliyah to walk through the study. She's going to do a brief review of the methodology and the assumptions and the things that have changed in this version, and then go through the results, the new results. Following that, I'm going to do a walkthrough of the high performance ordinance structure that we and many others in the Reach Codes realm have been working on. You may have also heard us calling it one margin. We don't really quite have a good name for it. So I'll ask the group if there's somebody in the group that's good at these things, we sure could use your help on that. Okay, so let's go ahead and get started. Jump on in. I think most of you already know that one of the things our program does each cycle is to complete cost effectiveness studies to support Reach Codes. And we completed this study a little bit more than a year ago. Typically we do this once a cycle, but things have changed so quickly and so significantly in this really short time that the changes have been significant enough that we're a little bit uncertain about how that might impact the results. Enough so that we decided it was worth going back and updating everything to reflect all the current conditions. And so that's what we've done here. In 2021, the primary interest in ordinances was really only in electrification. There were no jurisdictions wanted to add additional requirements for all electric homes, so we really hadn't pursued this option in the past. But with the recent CRA Berkeley ruling, it kind of forced us to re-examine the different kind of structures and options. And so we've come up with a new one, old. It's really more like a traditional Reach Code. But there are still many different structures that are out there. So I kind of just run through these right now. Basically like 4 different structures. And all of these options remain. And I do want to point out that we are not lawyers, and this is not legal advice. You must consult your counsel regarding the specific legal risks associated with any option you pursue, not just even things that are described here. I just want to make that point. Please consult your attorneys. Okay, but anyways, there are all options out there right now. However, from what we've been able to discern, they're all available, but they each are associated with a certain level of risk. And so we've tried to categorize that level of risk here a little bit. And so I'm going to work backwards from the right and start with what we've categorized as more risky. We've categorized the gas bans in this category as the most risky right now, primarily because they are the subject of the Berkeley lawsuit. And so that does seem to be very risky, although the all-electric building code amendments effectively have the same impact, though they do use a different mechanism. So one could argue that they're both equally risky, or neither, or one should be ahead of the other. It's fairly uncertain, but we've just tried to create a little bit of a spectrum here. Continuing towards the left to less riskier, we have the electric preferred structure. This structure was actually very popular in 2019, and that structure requires that mixed fuel designs meet a higher performance and a higher performance requirement, and all electric designs only have to comply. In doing research after the ruling, we've looked very closely at some of of course, at the EPCA language, but also at some of the previous decisions. And based on those, it has occurred to us that there could be questions about that design, that it could be interpreted as possibly not being even-handed and not offering equal credits for different things. So we consider that there is some risk there. How much? We don't know. That's just very dependent on the actual jurisdiction and the people in your jurisdiction and what's going on there. So least risky would be a traditional reach code. And that is what we're looking at now, that requires high performance for everybody. The same high performance required for both all electric and mixed fuel designs. This is a fairly conservative approach. It allows mixed fuel buildings as well as all electric. But we believe it is actually in the EPCA box. And so we think that it is the least risky of any of the options. Go ahead. Can you advance the slide for me, Elia? Thank you. So looking at that particular high performance design, what are we trying to accomplish here? What are our intended effects? Well, of course, we want to focus on carbon reductions. And so this design effectively establishes a carbon budget proxy. It's not exactly a carbon budget. It's still based on energy, but the source energy happens to follow carbon emissions. And so we wind up with a bit of a proxy here in this. We want to encourage all electric construction, of course, and take advantage of the fact that with this metric, it's easier for all electric to comply and exceed the code with using heat pumps than it is for mixed fuel designs. And lastly, we'd like to keep the requirements as simple as possible. In the last round of ordinances, there were a lot of caveats and exceptions and new definitions and a whole lot of other things. And it wound up being fairly inconsistent across many jurisdictions and confusing for some folks that are trying to implement. And so one of the goals here was to keep this very simple, keep it streamlined, and just require projects to achieve a certain level of performance. It doesn't require a whole bunch of other definitions and things like that. Primarily because we're not really restricting or narrowing any of the options. So there's people just have to do better. That's all we're really requiring. Okay, can we get the next slide? I wanted to bring this other option up, the passive house option. We wanted to just mention that this is a possible alternative compliance option. If you're not familiar with passive house, one of the principles of passive house is to optimize the envelope to minimize the heating and cooling loads. And so it's a great design strategy. It achieves incredibly high performing homes, and it could be used as an option. There's also many different benefits in addition to the reduced loads, right? You could have, it actually produces a more comfortable home. Typically improves air quality because of not pulling in outside air from places like perhaps your crawl space or attic by making sure your envelope is nicely sealed. And it also provides additional resilience so that somebody could potentially ride out a power outage or a wildfire or things like that more comfortably within their home. So one way to encourage these designs would be to offer a compliance option. And so that might be that somebody could either meet the advanced performance requirements with the EDR margin, or they could just show compliance with the state code and with passive house. And so it's one way that people might be considering it. We have not had any requests for this type of analysis yet, but we do encourage you, if you are seriously considering this option, please contact us, because we do need to take a look and do a little bit of analysis to determine at what level the passive house design, where would that fall relative to the EDR1 margins in each climate zone. And so if you are looking at something like this, please email us, call us. Our contact information is on the last slide here, and there's also an email here. Okay, I want to make sure that people are aware that this is an option, and really it's a great program. And okay, with that, I'm going to go ahead and turn things over to Aaliyah to go through the study and the results. Take it away, Aaliyah.
Great. Thank you so much, Misty, and thanks everyone for joining today. I'm going to start and try and ground us all with a little bit of background on the analysis methodology and what has changed before we jump into the results. So at a real basic level, the approach that we use across all of our statewide REACH code studies is first, we estimate building energy use using simulation tools for a base case and various above code packages. So this study is looking at electrification measures, efficiency measures, PV, above code minimum, and battery storage. And the 2022 prescriptive requirements per the energy code are our starting point. So that's the baseline. We then estimate the costs associated with these upgrades over the analysis period and calculate the energy benefits. And there's a couple ways we do that. I'll talk about that more in a few slides, but one of them is utility impacts. So we calculate first year utility impacts. And then we take all that together and determine whether, according to these assumptions and the methodology, a package or a measure is cost effective over a 30-year period of analysis. So Misty mentioned that we published a report about a year ago, and there's been a number of things that have changed since then. What is included in these updates is simulation results have been updated to reflect the latest certified compliance version of CBEC Res. There's been a lot of changes with utility tariffs. We now have the new net billing tariff, which governs how utility costs are assessed for homes with PV. Alongside that, the utilities have put out new tariffs, some that need to be coupled with this new MBT tariff, other electrification tariffs as well. So we've updated the electricity side of calculations, utility calculations. We've also done that on the gas side and introduced a slightly new methodology to calculating our gas costs, which use annual trends over the last 10 years and apply this to the most recent gas tariff to develop, an average monthly normalized rate, 12-month normalized rates. There's a couple updates on the incremental cost side primarily that impact heat pumps. So there's been some data collection that we have taken on this year, and so we've incorporated that into the analysis. Also, the last study did still include gas line extension allowances, and those have been removed per the latest CPUC rulings. There's a couple revisions to how we've packaged measures together, and I'll go over that in a couple slides. And then lastly, we received a number of requests from jurisdictions over time for looking at these results in different ways. So we've done some additional cost sensitivity as a result of these requests. And there's three things that we've looked at that we'll present to you today. One is the impact of future equipment costs. So we know that a lot is changing, and when it comes time to replace equipment, what are those costs going to be? We've looked at a 15-year period of analysis alongside the 30-year in one scenario, and then we'll also look at the impact of escalation rates, utility escalation rates. So these are the prototypes used in this analysis. These also are the prototypes used by the Energy Commission in their code development process. You'll hear me refer to in the results single family and ADU. So the single family results represent this average of these two prototypes. So a 1-story, 2,100 square foot and then a 2-story, 2,700 square foot. And then separately, we have an accessory dwelling unit, or ADU, which is a single-story detached 625 square foot unit. We'll share results both for mixed fuel and all electric homes. So there's the prescriptive base case, which reflects the 2022 code. That is a mixed fuel home. And I'll remind everyone in a couple slides a little bit about the heat pump baseline and what establishes that code minimum. Then we have a case where we keep everything prescriptive except the appliances, and we'll convert everything over to all electric, no gas on site. We layer on efficiency. We layer on high efficiency equipment. This is a new package that we've added. Now, we've had it in prior code cycle reports, and in our last report, we did not include this, as it cannot be the basis of an ordinance because of higher efficiency equipment and federal preemption. But we decided it's really useful to compare against all these other packages, and this will come into play more when Misty talks us through the EDR1 design towards the end. So lastly, PV, so above code PV. In most cases, single family homes are going to have PV on them to be code compliant. And so this is increasing that PV capacity amount. And lastly, coupling that with battery storage. Now, in this presentation, we're showing just a subset of these results that demonstrate what we think are the important results and conclusions to share with you today, but the report will include a full set of results. Okay, so just a couple slides on costs here. There's two methodologies that we use in all of our statewide REACH code technical analyses to evaluate cost effectiveness. The first one is on bill, or we sometimes think of it as this customer focused perspective. And with that, we calculate annual utility costs that are based on time of use utility rates that are selected for each climate zone based on the predominant utility serving that zone. In the results, you'll see that some climate zones there's results presented for them for multiple utilities where their service territories cross over. In the report, we will also have results for SMUD and City of Palo Alto utilities, but today we'll just be sharing the IOU results. And then we apply assumptions for escalation of those rates over time to estimate impacts over the analysis period. And then we have TDV, or time-dependent valuation, which is a code-compliant metric that the California Energy Commission uses in their code development process. And it evaluates more than just the impact on utility bills and is meant to reflect the longer-term cost of operating and maintaining our energy system in California. It, by nature, is a 30-year metric. The on-bill metric is converted to this 30-year metric by applying these escalation rates. And you'll see in the results that the impacts of applying these two methodologies are quite distinct, and that has changed over code cycles. They've diverged more and more. So hopefully some of this gives you some background on why these results might be different, and they're really fundamentally distinct in how they evaluate the cost side benefits of energy. So I'll be presenting results according to net present value, and so we talked about the benefit being evaluated over the 30-year analysis period. The costs also are evaluated over that same analysis period, and so where equipment needs to be replaced during that period, we're incorporating replacement costs. If incremental maintenance costs also would be assessed, that's also incorporated. So that net present value is the present value of the benefit less the present value of the cost. So I mentioned that the heat pump costs have been updated, and I'll share with you what those are. So the 2022 Energy Code has a heat pump prescriptive base case, and this applies one heat pump prescriptively in each home. So in climate zones 1, 2, 5 through 12, 15, and 16, it's a heat pump water heater. Alongside that is prescriptively, it's assumed there's a gas furnace and AC. So in those climate zones, we're converting that gas furnace AC to a heat pump space heater. We have some new costs that were collected from contractor surveys that we're using here. And we're also incorporating the impact of sizing by climate zone. And this was something that we didn't do in the report last year. In many of the climate zones, based on the balance of the heating and cooling load, we would end up with the same size air conditioner as we would a heat pump. In some climate zones that are more heating dominated, however, we end up with a larger heat pump than we would the air conditioner. And as a result, that's factored into the costs. And so you can see on the incremental first cost that in many of these climate zones, there's a negative number. That means it's cheaper to install the heat pump than the air conditioner furnace. But in a couple cases, climate zone 1, climate zone 16, because of this difference between capacities of these two system types, there's a higher cost for that heat pump system. So that's the first cost. And then the lifetime incremental cost includes, like I mentioned, replacements. So we're assuming a 15-year lifetime for heat pump and air conditioner and a 20-year lifetime for furnace. Here's the heat pump water heater cost. So these get applied in climate zones 3, 4, 13, and 14, where prescriptively there's a heat pump space heater and gas tankless there. So we're converting from a gas tankless to a heat pump space heater. And these also reflect some updated costs from surveys from this year. And the lifetime costs assume 15-year lifetime for the heat pump water heater and 20 years for the gas tankless. All right. Maybe before I jump into the results, I'll just stop and check if there's any questions. Misty, has anything come up?
No questions in the chat yet.
Okay.
Any other questions? Somebody want to you can go ahead and raise your hand if you have a question also. Not yet.
All right. Well, I will just keep going, but please raise your hand or add anything in the chat if you have any questions.
Just as I was saying, there wasn't any. We got one. Kelly, go ahead.
Kelly, we can't hear you. Are you unmuted? Might be having audio difficulties. If you want to try putting in your question into the chat, we'll address that. Or maybe we can try again in a little bit if you are having some audio issues. Okay, and I see Bo's hand is raised too. Want to go ahead?
Thank you, Aaliyah. Sure. I'm curious if the team thinks that it might be useful to assume that a heat pump will be required after 2030 because of the CARB ruling. And I know I brought this up before, but and that's into the future, but it's right at that time where you're going to have your replacement of the equipment. And it seems like that ruling is pretty much guaranteed to be enacted. I'm curious what the team thinks, or if at least the note could be put in the report that wasn't included.
Yeah, that's a great question, Bo. And I think at minimum, we will be including some discussion of that in the report. We actually are looking at that now on the alteration side with some of the retrofit analysis scenarios that we're doing for an updated reach code analyses there for existing single family homes. And it makes this analysis a lot more tricky, particularly on the TDV side, where it's not straightforward to evaluate different scenarios, different kind of energy profiles over that 30-year scenario. But it's an absolutely valid point. And so at minimum, we'll be discussing that, and perhaps we can, what I'd like to be able to do is look at a sensitivity scenario of that, and provide some feedback to stakeholders on that.
And that 15-year analysis that you did also will give us some insight into that, right?
Yeah, that's right. Mm-hmm.
Kelly put her question in the chat.
Okay.
And she asked, this doesn't take into account incentives, correct? How could those be considered also?
Yeah, great question. Yeah, so the results that we'll see today do not take into account incentives. We have provided some sensitivity of that in the past and plan on doing that in the report. That is fairly straightforward to take into account and kind of look at different scenarios. Okay, if there's this much upfront incentive, how does that impact the results versus if it's that much? And so that's also something that we can work individually with any jurisdiction on if they have particular scenarios that you want to evaluate.
Thanks, Leah.
Great.
Doesn't look like there's any more questions.
Thanks, everyone. Okay. All right. So so I wanted to look at this first as a reminder of where we are today with the energy code and the impact of electrification on code compliance. So with the 2022 energy code, there was a lot of changes. We got new TDV multipliers, new weather files. There was a new metric that was introduced, source energy, this EDR1, right, that tracks greenhouse gas emissions. And now we have these two different metrics that have to be met for a project to be code compliant. So on the bottom left side, this graph shows EDR margin, which is the margin above code minimum. So positive margin means you're exceeding code. And this is for an all-electric prescriptive home. So in every case, an all-electric, if you just build all-electric and meet the minimum prescriptive requirements elsewhere, you will exceed code. The corollary is that if you now try to go back to a 4 gas appliance home and convert that one heat pump back to a gas appliance, then you don't meet code. And in some cases, you don't meet code by a pretty significant amount. And you're going to have to make that up in some ways. So next I'm going to step through the cost effectiveness analysis results, but wanted to start with this to remind us all of this reality, because it will come up again when Misty shares the updated EDR1 results and talks through the high performance strategy. All right, so we're going to look at cost effectiveness results for a number of all electric scenarios to start. This is the prescriptive code minimum for the single family prototypes. And what this graph is showing is net present value. So when we have an NPV of greater than 0, then we have a scenario that's cost effective. If it's less than 0, so below that 0 line, then it's not cost effective. The blue bar is results from the 2022 TDV methodology, using that methodology. And the gray is using the on-bill methodology. So the result is that using 2022 TDV, all of this package is cost effective in all climate zones with one exception, and that's climate zone 16. This is similar to what we had in our prior report, that this package was TDV cost effective. The difference is climate zone 16, and the change there does have to do with what I showed on that cost slide, where now that we're incorporating the capacity differences between an air conditioner and a heat pump, that the first cost of that heat pump system in that climate zone did go up and did result in this new outcome. From an on-bill perspective, this package is cost-effective in a handful of climate zones. Most of these are in SCE territory. For most cases, the lifetime benefit, that lifetime NPV is not very large, a few $100s positive or negative. The two exceptions are climate zones 1 and 16, which have a higher heating load and cooler temperatures. Okay, so this is the same package, same results, but for the ADU. And in this case, this package is cost effective based on TDV. In most cases, it's cost effective where we are going from a gas furnace AC to a heat pump space heater. Where it's not cost effective is in climate zones 3 and 14, where we're moving from a gas tankless to a heat pump water heater. And what's going on with the ADU is that in the single family home, the heat pump water heater is assumed to be installed in the garage, which is a more straightforward and less costly installation. In the ADU, this analysis assumes that it's installed in the conditioned space. And so our modeling and our cost incorporate for ducting of that heat pump water heater, both the inlet and the exhaust streams. And that results in a larger incremental first cost, and not as much more cost that has to be traded off against that benefit. And the outcome is that in those two cases, it doesn't turn out to be cost effective, but it's very marginally uncost effective. On the on-bill side, there is a positive cost effectiveness result in a handful of climate zones, but in most, it's a negative net present value. Next, we're going to look at adding PV. So, as I mentioned, to meet minimum code requirements, there is a PV system on most or all single-family homes. So in our analysis, we assume there would be a PV system that meets the minimum capacity per the prescriptive requirements. And this is adding, this is electrifying the home, adding some efficiency measures, and then adding a PV system that offsets 100% of the annual electricity use. Now, this used to look really great on bill under NEM 2, where as we incrementally increased that PV size, the incremental benefits were almost linear to that, incremental cost increase. Now, under the NBT model, as we increase that PV capacity, we are exporting more of that on-site generation to the grid. Those exports are valued significantly lower than what we pay for electricity coming into the house. And so to the extent that those exports can be minimized, we find outcomes that are much more cost effective. So in this scenario where the PV is offsetting annually 100% of that electricity use, the outcome still is on-bill cost effective in a number of climate zones, not all, but at a very different degree than what we've seen in our past analyses under NEM 2. But under 2022 TDV, this package is still cost effective across the board. Okay, so same package with all electric, efficiency, and PV, but for the ADU this time. And there is a couple things that are different here. Again, just like with the heat pump water heater, there is an exception in the 2022 Energy Code that says if your requirement prescriptively for a PV system is 1.8 kW or less, you're not required to install a PV system. And so this does come up for the 625 square foot ADU in almost all climate zones. There's a couple of exceptions, 10, 11, 13, and 15, where in the base case, there is a PV system per code. In the other climate zones, there's not. So in those other climate zones, what this package is evaluating is electrification, efficiency measures, plus adding a PV system where there was not a PV system before. That does end up with a result that is more beneficial on bill, because we're getting all of the cost savings from the utility cost savings from installing that PV system. So we have better on-bill cost effectiveness here, and we also have TDV cost effectiveness across the board. Maybe I'm going to jump, before I jump into some first year utility cost impacts, I see that there's a couple chat items that maybe we should address.
There are, yes. We have a question from Claire. She is wondering if there's any place in the codes or any opportunity at a municipal level to actually discourage the construction of single-family homes.
That's an interesting consideration, and I'm guessing you're talking about as opposed to investing in retrofitting existing single-family homes that are in the.
Yeah, I believe she's asking if, just encouraging discouraging the development of new single-family homes everywhere, and moving more towards a multifamily structure. I think,
right.
And please, folks, I know there's a lot of jurisdiction folks on the line here. If people could chime in, I think that would be done at either maybe a planning commission or zoning. Is that correct? I'm not sure which is the appropriate venue, but yeah, it would be at a local level. There may be other places in the codes, but I don't think in the building code. I think the building code assumes you're already building something, and not trying to control what it is you're building.
Yeah. Thanks.
Okay, and then Alice also had a question about ADUs in climate zone 3. And she asks if installing the heat pump water heater outside the heated envelope, say in an attached exterior closet, were legal, couldn't that prove cost effective?
Good question, and it depends on the climate zone. There's impacts of locating that heat pump, that tank and the heat pump water heater outside, energy impacts that will be accounted for. That in the colder climate zones, it's likely going to hurt that cost effectiveness. But in the milder climate zones, yeah, I think generally it does. We are looking at that sensitivity, the location of heat pump water heater, that is, in our retrofit analysis. We could do that too in new construction if that's something of interest to folks. We can talk about that more offline.
Okay. Thank you.
Okay.
Alice clarified a little bit here. She said she was asking about climate zone 3 specifically, which was the puzzling ADU case.
Yeah, climate zone 3. We need to look at those results in climate zone 3. And like I said, we do have that sensitivity already for existing buildings. So we could take a look at that and share some of those results with you. We can follow up.
Right. Okay.
All right.
That's it.
Okay. Okay, so we've been looking at net present value, and we're now going to look at a couple of slides that show first year utility costs. And so this first slide is showing this for single family, all electric prescriptive code minimum. And the y-axis here is the impact relative to the 2022 base case home. So a negative value means that this all electric home costs more to operate in the first year from a utility cost perspective than the mixed fuel base case. So for this prescriptive minimum home, the impact is on average about $300 per year increase in utility cost. As we then layer on measures, efficiency measures, and high efficiency heat pumps, in this case, that increase is tempered quite a bit, and there's actually utility cost savings in a couple of instances, but on average about a 100-year or $100 per year increase in utility cost. Then if we add PV, we just looked at these net present value results that showed, well, they're not as great with the new MBT, but adding PV still does provide utility cost benefit. There still are savings that we're seeing from increasing that PV size above a code minimum amount. And then lastly, you'll see why these bars are so small compared to the y-axis scale there. Adding battery. With NBT, as I mentioned previously, the value of exporting PV is substantially reduced relative to NEM2. Any strategies that keep that electricity generation on site to use it later, so better on-site utilization of that PV generation, have substantial benefits, as you can see with this scenario. So when we couple that PV with on-site battery that is set up to optimize utilization on site, there's substantial benefit of utility cost benefit from doing those two things. Even though batteries are a high first cost, this may be something that builders and consumers should be considering as they're sizing PV systems in conjunction with MBT on new homes. Another thing I want to point out is that we aren't, in this analysis, we're not assuming other loads kind of outside of the boundary of our typical home loads. So maybe the first one that people are thinking of is EV charging, pool pumping, other auxiliary loads. While incorporating those won't have a substantial impact on the results, there will be a second order impact where, as you increase your electric loads in your home, electrifying more things like transportation, then adding more PV capacity, does make more sense. And if you can still balance that right under NBT to try and optimize that from a utility cost impact. Okay, a couple of slides. We're just going to look at one mixed fuel package. So for those of you that are familiar with the electric preferred approach that Misty mentioned at the beginning of the presentation, this mixed fuel efficiency plus PV plus battery was that full push on the mixed fuel side that was being used to kind of represent the target that could be set for a mixed fuel home under that electric preferred scenario. And Misty will talk in a little bit about how this kind of fits into the new structure. But these are the cost effectiveness results. It is cost effective on bill in all climate zones. And that's really stemming from what we saw on that last slide, where there's this big benefit from coupling batteries and PV. It's cost effective based on TDV in only a couple of climate zones. And this is flipped from what the results that we had in the past analyses with the prior NEM2. And as well as we were controlling the battery a little bit differently to optimize actually discharging to the grid when it was beneficial from a utility rate perspective. Now with MBT, we've revised how the battery is controlled in the simulation to better reflect how we think they will be set up in real life. So that supports the on-bill results. It ends up hurting the 2022 TDB results some. And here's the same results graph, except for the ADU. It's cost effective on bill in most climate zones, almost all climate zones, and it's not cost effective based on TDB anywhere. All right, so a couple more slides here presenting this sensitivity analysis. That these are various things that have been requested over time by jurisdictions to look at to better understand how these results change based on different assumptions. So the first one that we're going to look at is the analysis period. And it's very hard to predict what will happen over the next 10 to 15 years, much less 30 years. There's absolutely advantages of using a long analysis period and evaluating the benefits of certain measures over that period, such as insulation measures that perform over many years, more than 30 years. And so we have moved towards this longer analysis period, 30 years, to better capture long-term benefits of those measures. So there's absolutely advantages of this longer analysis period, but with these challenges of estimating future utility costs, system replacements, when is it that gas equipment is not going to be available, we thought, let's see what the impact is with a shorter lifetime. And this eliminates some of those uncertainties. And you can see, so that the green bar is what we've seen in the previous slides. The blue bar is revising that to a 15-year analysis period. And the results improve quite a bit. The benefit here is that, you know, this 15 years eliminates the need to consider equipment replacement at end of life. Also, there are first cost savings. We're assuming there's, you know, pretty substantial first cost savings for an all-electric home versus a mixed fuel home, largely due to the elimination of gas infrastructure. But, you know, also there's some first cost savings for heat pump equipment, and that ends up being spread over a shorter lifetime. So that's another kind of implication of this analysis that's resulting in improved results. The next one is keeping again at this 30-year analysis period, but playing with what do we expect the future cost of gas system equipment is going to be at time of replacement. And so this assumes that there will be a 30% increase. You know, it assumes that gas equipment still will be available, you know, to Bo's question earlier. We're assuming it still is available in this scenario, but it's going to cost more. And in this scenario, 30% more. So this has a similar impact as the change in lifetime, where it improves cost effectiveness across the board and ends up flipping the outcome in some climate zones from not being cost effective to being cost effective. The last one is escalation rates, which ends up having the biggest impact. So the results so far have been using escalation rates from a CPUC en banc proceeding a couple years back, coupled with the escalation rates that are ingrained in 2022 TDV. So where for the years that we had an escalation from the CPUC data, we applied that. For the other years, we applied the 2022 TDV assumptions. And that's what's been in all the results that we've seen so far, and that's what was in the published report from last year as well. As part of the 2025 Title 24 code cycle, there's a new set of metrics that were developed. There's been a change in name. So from TDV to long-term system cost, or LSC, the methodology is the same, new name, but very different values and metrics and different assumptions that went into it. And one of those was that there's a very steep increase in gas costs over the particularly the last 15 years of the 30-year analysis period, and that electricity rates do not climb at that same rate. So you can see that has a very significant impact on the results. And using these rates, the outcome is that an all-electric prescriptive home is on-bill cost effective in every climate zone. I guess one thing I want to point out is we're presenting the sensitivity. It is hard to draw a single conclusion or recommendation from these analyses. Where I think we can go next is an ongoing discussion with jurisdictions on your perception of these analysis results and how you think they're useful for where you're going with an ordinance. And you know, we're interested in getting feedback from you on how useful these are and as well as if there's any other scenarios that may be useful to view alongside these. So, we really appreciate the engagement and the feedback that we've gotten over the years in terms of what would be useful to see as you go through your process. And this is in response to that, and we hope to have an ongoing dialogue about this and other aspects as well. So that is my last slide. We can again pause for questions before I hand it back to Misty.
Okay, we do have a couple of questions in the chat,
Okay,
Aaliyah.
great.
Before we go to those, though, I just wanted to add one last thing too about the sensitivity analysis is that we're also aware some of the feedback we've received is that it can also cause some confusion to have two sets of numbers. And so we're also aware of that sensitivity. And so your feedback and what you really would like to see is really important for us to know how to structure everything here. So please don't be shy about that. Okay. Okay. Let's see here. We had a suggestion from Alice about one of the graphs, which I'm not going to read, but I agree is a good suggestion, and we will definitely take a look at that, Alice. Thank you.
Thank you, Alice.
Yeah, and then Jeff Masad asked if the cost-effective model or calculator will be available as open source to various projects so that various projects could be tested against the assumptions, like with actual construction costs and utility rates and things like that.
We thank you for that question, and we have spent quite a bit of time talking about what would be feasible there. Long term, we would love to be able to provide that, and have talked through some strategies to be able to kind of package up our tools in some way that could be provided to all of you to use in a very flexible manner. So I guess, one of the answers is that's an ongoing discussion and an effort from the Reach Codes team to be able to, provide more tools that give you the flexibility you need. I guess the other response, Misty, do you want to say something about the cost effectiveness explorer and how that is at least on the existing building side responsive to that in some ways?
Yeah, we do have some of the you can play with some assumptions and different policy types and things like that via the cost effectiveness explorer, and we also do publish our data, the results. I think that's about as far as we go with that at this point, though we are looking at, you're right, at ways that we can do that, Aaliyah. I also wanted to also point out that we try to kind of, our goal is to provide a bigger, higher perspective look and not look at individual projects necessarily. We know that different projects are going to perform differently and have different experiences, but we're trying to kind of look at just a generic project for this purpose. So that's why you see the results the way they are.
Yeah, good point.
Yeah. Okay. And okay, and then Alice had a comment about that. She noted it was a good question. Yes. Particularly in the slide that presented the non-cost effectiveness of PV plus batteries with setting to not discharge to grid. I'd want to see the chart for results with an optimized sizing of PV and battery with optimized controls. Agreed.
Yeah, right. So it is cost effective on bill. It is shown to be cost effective on bill. But if you did control the battery differently, that TDV result would change substantially. Yes.
And Bronwyn asks if there's a chance that metrics for this new TDV iteration can be translated into metrics that can be measured on site. Question.
I doubt that.
I wouldn't know how to go about it.
It's with that does come up, right, on individual projects and looking to actually validate the operation against the design, particularly if TDV was used to decide, make design decisions. But given that intrinsically TDV it incorporates so many aspects of our larger scale, system-wide, statewide energy system and societal impacts, it's a very hard thing to do. And maybe, I think there's some data available to inform real time some of those aspects that go into the development of TDV, but I'm not sure all of them.
Thank you. And Alice notes, Tom asked a good question, and cost effective for whom? Is it the customers, the ratepayers, or the utilities and the grid?
On bill, net present value is all of the sensitivity results were presented for on bill. Thank you for that question.
Okay. Oh, I skipped Tom's. I apologize. Thank you. Okay, and Bronwyn had another question as well. TDV per square foot per year is a totally obscure value that can't be verified on site by those of us that are interested in tracking our projects. It creates a serious disconnect from the field. I hope you'll reconsider.
It's absolutely. I mean, I think for verification, we need to be looking at different values. TDV does support some of the packages in this analysis that we all here are looking to encourage in homes, like the all-electric design. So there are some benefits of looking at the cost effectiveness outcome from that perspective, from a broader perspective. With that, it also brings some challenges of how to kind of a level set with that and understand it and apply it in reality.
It really does. And that's part of the reason that we do the on-bill perspective as well, to try to give at least the individual's perspective as well as the larger perspective. But it is a very difficult thing to relate to. It's true, Bronwyn. You have a very good point. Okay, do we have any other questions? Oh, I see a hand. Bo has a question.
Yeah, thanks, Misty and Aaliyah. So it's related to the 15-year versus 30-year. I'm curious if perhaps we could get the Energy Commission's opinion on whether we could just only stick with 15 and get rid of the 30, because when you include 30 and you're allowing gas equipment at that point, it's having a very large impact on the overall on-bill cost effectiveness, even though we can almost say with certainty that you won't be able to install that gas equipment. And then the other reason it kind of compounds that problem is the lifetime of the equipment. So the lifetime of the heat pump's only 15 versus 20 for the furnace. So it's overemphasizing the value of that furnace. And that's even further out. And we're not going to be able to put another furnace in at that point. So it's like we're valuing the gas infrastructure a lot, whereas we should really be devaluing it because it won't be able to be used. The infrastructure won't be able to be used at that point when there's a replacement. So if we can get buy-off from everybody and CEC to just go to 15 years, I think that could be more accurate. And then another comment related to that, I think it'd be nice to see in some of the plots in the report, the cost broken down by the first cost versus the benefits. So we got the present cost of the present value of the cost and the present value of the benefits, and show them separately so we could see which is having a large impact. That might be useful. And yeah, those are my main comments. Thank you.
We will, so I'll respond to that second one first. We will have that in the report and the data that's published. So yeah, that is useful to see. On your first point, my sense is that the solution isn't necessarily to just move to a shorter life analysis period, because partly because of there's many advantages of looking at a longer lifetime for many measures, and I'm not sure we want to change our approach entirely for electrification. That being said, there may be different ways that we can look at and value the energy streams and the cost streams across that 30-year period to take into account what you're bringing up, that let's apply an assumption that 10 years from now, or 2030, whatever that year point will be, we aren't going to be able to purchase gas equipment. So then we have different energy streams per year. I commented that does make the analysis much more complex, but maybe that's what needs to be taken into account in the future. We also have different cost streams where, we're replacing, in our base case, we're installing heat pumps down the road when equipment fails. And so that's another thing that I know the Energy Commission is looking and thinking about in terms of measures that are being considered for the 2025 cycle and how to accurately reflect all of that.
Aaliyah, may I add a little bit to Bo's first question? A local jurisdiction could use a 15-year analysis period in their analysis. The determination of cost effectiveness is entirely within the jurisdiction's authority. And so they could use that. You would, of course, have to explain the rationale for not sticking with the state's process and the way that they analyze things. So, but it does not require CEC buy-off. CEC doesn't actually review the cost effectiveness calculations or actually opine on them at all. They only do an administrative check. So a local government could, but Aaliyah also points out that from this perspective, it probably would make sense, but there are other values for the 30-year cycle too. We'd have to be careful. But yeah, that it is possible.
Yeah, thank you. I see Kelly has her hand up.
Oh, Misty just said exactly what I was going to say, is that it really is up to the jurisdiction. And one of the reasons the REACH Codes program has chosen to invest resources in sensitivity analysis that are outside of what's done for the base code, and especially the on-bill calculations, which are not part of necessarily the Title 24 statewide baseline code work for many, many reasons, including the complexity. And it's, we've done all these additional slices of analysis because of that, because jurisdictions can choose how they value that. But those windows, those walls, those insulation values, et cetera, yeah, I mean, we want to consider the things that aren't going to take a swap out or change to adjust. So that, and 30 aligns with the Energy Commission's current thinking on the baseline code. So those are the rationale. So thank you.
Excellent.
Thank you, Kelly.
Have any other questions or comments here? Let's see. We've got a couple of comments in the chat.
Yeah, it looks like some dialogue about TDV. I'm trying to see if there's a question that we should answer.
I don't think so. Alice asked why we're using TDV when it's pretty meaningless, and great question to which I don't think we have the answer. I think that would have to be addressed to the CEC directly.
And just, echoing what both you and Kelly just said, is that it is up to the jurisdiction what they want to use. So if you want to ignore the TDV results, you may, and just focus on the utility costs.
Indeed. Okay.
Okay. Well, want to take it from here, Misty?
All righty. Great. So I know that was a lot of information to digest. And I just want to point out it takes us quite a while to do that too. So it takes a little bit of time to finally, get it in your head. But I did want to also note that Aaliyah and I are available, as are others on the team. Should you have any questions as you're looking through things later, as you're going through the report, or at any time really, don't hesitate to give us a call. We're happy to look at things, walk you through whatever your question is or investigate it with you. So we know it's a lot of information to get at one time. So really don't hesitate to follow up. But for now, let's go ahead and take a look at a potential design that is really kind of similar to our traditional breach code designs and requires equal high performance for all new construction, both all electric and mixed fuel. So following the CRA ruling, when we were looking at a structure here, we had a couple of primary objectives. And the first one was to make sure that any structure complies with the EPCA requirements, the Energy Policy and Conservation Act. We don't want any policy to even, to have there be any question about whether or not it should be preemptive. There are 7 requirements that have to be met in that realm, and 3 of them really apply to us directly. The first is, and Aaliyah's mentioned this already, there has to be a compliance pathway with appliances that are standard efficiency. They don't exceed the minimum federal efficiency standards. So you cannot specifically require that people use high efficiency equipment. To be clear, when people build, they are absolutely allowed to, and many people do, but you can't specifically require it. The second one is that the conservation objective actually has to be specified in terms of energy or its equivalent cost. This actually has come up in a new lawsuit against the state of New York that was filed a week or 2 ago as one of the issues, because they had an emissions objective. And so that came up as one of the issues there. Even though our goal is to reduce emissions here, the Energy Commission has set things up for us handily. They have found a proxy for that, and it's the hourly source energy, that EDR1 number we've been talking about. And so we can make our objective be based on energy that way and still target emissions. Sometimes it's a little bit of a finding the right path through. The credits that you offer have to be based on a 1-for-1 equivalent of energy use or an energy cost basis. Okay, so you have to offer even credits. You can't just credit something that is more desirable. You can't give it more credit if it doesn't save more energy. They have to be equivalent. They do not necessarily match exactly. That's almost impossible to do with different measures, but they do have to be roughly equivalent. And then, as I said, there's 4 other requirements that really don't impact our design very much. One of those is using like standard test methods for the equipment and things like that. But these 3 we wanted to make sure we addressed specifically. Of course, we want to comply with the state requirements, so the ordinance has to be cost effective, and it has to be more stringent than the state code. It has to actually result in a reduction of energy use. Okay. And lastly, we really wanted it to be easy to implement. So the ordinance structure uses the existing compliance metrics, the existing forms, processes, nothing changes. The number that the plan checker is looking for is right on the form. There's no extra calculations or anything like that. That was kind of some of our main objectives for this ordinance. Okay, next slide, please. Aaliyah showed this slide previously, but I just wanted to quickly look at it before I start getting into the specifics of the ordinance. It shows the compliance results for a prescriptive home, which is an all-electric home, which keeps all of the same prescriptive assumptions from the base case, but just switches the equipment to electric. And what you can see is that home gets a credit in almost every single climate zone. And so what we found is that all else being equal, the all-electric design actually performs better under this metric. And so the idea is to leverage this structure and to use it to our advantage as much as we can here. Okay, next slide, please, Aaliyah. I'm going to have to, this one's animated, so I'm going to have to walk you through as we go. Next. Okay, so the ordinance structure kind of still seems a little bit abstract, I know. So I'm just going to walk through this example that I think may illustrate the idea a little bit better. In this example, we have 5 different packages that build incrementally. We have the code minimum prescriptive package, the efficiency package. Next is the one with high efficiency equipment. That's the preempted package. We can't use that as the basis for our design, but it's very helpful information. Then we add PV, and finally storage. And Leah, if you could go ahead and hit the next one, I'd appreciate it. What we can see here, this first group of measures is the results for each of these packages using the all-electric design. And it shows the EDR1 margin on the y-axis for each one. What you can see is that those they incrementally get better as we add more measures. Okay, go ahead and add the mixed fuel. And you see essentially the same, not exactly the same, but a similar progression for the mixed fuel margin. Oh, go ahead and keep that there. There you go. So it's basically the same progression. Okay, but they don't do as well, as you can see. So we've got similar packages on each one of these, and then the mixed fuel just doesn't quite perform as well. Okay, so when we're looking at how might we design an ordinance based on these results, one of the things we know is that we want to push that mixed fuel design out to the edge of its cost-effective envelope, right? And so that would be this last run with storage. And so if you go ahead and hit that, thank you. That would be our maximum margin here that we would probably go for. We have a cost-effective option for both types of design there. However, if we were to choose that, we would be pushing the all-electric design at least to add PV and possibly even to storage, depending on the specifics of each project. And that's really not our intent. We really want to try to make it a little easier for the all-electric, even though we're requiring the same performance. And so one possibility would be to look at a slightly lower margin, right? And so this margin looks at the efficiency level, this kind of option A here. I did not select the PV level because it actually performs better than the mixed fuel with storage. And so we would not have a cost-effective path for the mixed fuel with that level. So it might just be a little too aggressive. And as Aaliyah showed, in some cases, going to that level isn't always cost-effective for the individual. And so we're looking more down at this efficiency level with a margin of about 10. At this level, we've got a really good delta between the all-electric and the mixed fuel results here, the two margins. Even if somebody were to add efficiency and high efficiency equipment or PV, they still would not be approaching a margin of 10 with a typical design. And so that margin just might be sufficient to push that mixed fuel design up to having to add storage in order to meet it. So we really want to push that as far as possible. The idea being, if you're going to build mixed fuel, you have to do it well and actually provide a little bit of benefit to the grid. And this is one way that we can actually get the mixed fuel design to offset some of the emissions. This gets us a much bigger emissions offset with the storage. In this case, you could even go lower. If you want to throw one more, you could go down here to the code minimum, maybe at a 9. And you'd see that it would still be quite a stretch for the mixed fuel to get there. Go ahead and hit the next 2 if you would, Aaliyah. We've got to look at the costs. In addition to the performance of the home, another possible incentive to build all electric is looking at that initial cost. At the code minimum level and here down at the efficiency levels, it's much cheaper to build all electric than it is mixed fuel. And so there's actually a savings beneath the base case here. And so that provides an even bigger incentive. As we start moving towards the PV and storage options, though, those costs converge and the all electric actually becomes more expensive to build. And so we would lose that financial incentive, but we could be very aggressive in the performance realm But we probably want to balance these two incentives a little bit more, and it might make more sense to back off a little bit here and look at either the code minimum or the efficiency level as a good range. I wouldn't recommend in most cases going below this code minimum level. There might be times you want to do that, but that would actually result in very likely the all-electric design trading off some of that credit in the envelope. And so it would probably reduce the integrity of the envelope to some degree, which is really not what we're trying to do here. We really want to maintain that basic envelope integrity so that we aren't increasing people's bills and creating, just unnecessary load that we really just don't need. Okay. Okay, so let's go to the next one. And I'm going to go through this one just a little bit more quickly. This is Climate Zone 6 down in Los Angeles area. And you can see we've got a similar progression. It's not as high. The margins aren't nearly as high down here at the efficiency levels, but it's a similar progression, building as we add more measures like we might expect. The mixed fuel design will do the same. And again, as we expected, not quite as well. Okay. So in this case, setting the margin might be a little bit different. We still have our maximum here where we've got, that would in this case be about, looks like 18, where we've got a cost-effective option for both mixed fuel and all electric. Probably wouldn't want to go above that. Okay. Or we could, that's still very aggressive though. That's very aggressive even for the all electric. You get a really big credit in Climate Zone 6 for the storage. It's really, really large there. So if we could bop this down here to the efficiency and PV levels. That might be a better option to look at here. That gives us, it looks like about an 8, margin of about 8. And a mixed fuel design at this with the same measures looks like it would get about a 3. So we've got a delta of about 5 there. Probably, even if we looked at the, adding high efficiency equipment, looks like it gets you 1 or 2 points there. Mixed fuel might be able to get there without adding storage. There's some possibilities with other measures that it actually could approach that level. We could still, though, go down and look at the prescriptive level. Here, down at 4, we still have a delta there, but it's a much smaller delta now, and it really may not be enough to push that mixed fuel home all the way as far as we'd like to push it. And so we see basically that this may not work in Climate Zone 6. So designing this structure is really going to be somewhat climate zone dependent on and how the results fall out, so that we want to make sure that we keep a big enough delta between the two different design types that we're forcing that mixed fuel design to go to the most cost-effective package as possible. So if you go ahead and put that was my next question. You're on it. Thank you. We see that basically the same progression happening with the costs. The initial costs down here at the prescriptive and efficiency levels are much lower. In this case, even at the PV level, there's a lower heating load here. And so adding PV to meet the whole load, it's not quite as big of a system. So it really hasn't closed that gap as much as it did in Climate Zone 3. But once you add storage, it does start closing that. But really what we can see is we still have the same motivation down here at the efficiency level. But that delta is a little bit iffy. In this case, we probably recommend going somewhere between the prescriptive level and the PV level, in that range. So between a 4 and an 8. Maybe the appropriate range is a 6, even though this isn't the run that we're using. Maybe that's a good range. It gives just enough to push it so that even if you added PV, you might not quite make it. You might still have to go to the storage if it was a mixed fuel design. So in some climate zones, we've got to be a little bit more thoughtful about where that margin really needs to be to actually achieve what we want to achieve as best as possible. So I hope that kind of helps walk through the the process of how we design these kind of ordinances and the structure and how you might want to go about that when you're looking at it. Again, we're always happy to talk with you though if you want to talk through something, always. So I'm just going to kind of quickly summarize this now that we looked at kind of how all the sausage gets made behind the scenes. What are the main features of this structure that we're looking at here? Again, we want to require higher performance, so we want to make sure that we're doing beneficial electrification, not just electrification. We want to try to reduce people's bills, not create higher bills for them. The ordinance uses source energy, which in this case is expressed as EDR1 as our performance metric. And as we discussed, that gives us a proxy for GHG emissions. And so they follow very, very closely. By doing that, we have a pretty strong encouragement to electrify, but still leaving a path for gas and making sure that that path for gas actually does provide some emissions benefits. And pushing it to that point to get some of those benefits, even if we do that. By setting that margin at the prescriptive level, you would avoid that kind of potential backsliding on the envelope features. And it also, because we now have a performance requirement beyond the base case, it includes an option to encourage the use of certified energy analysts and to document the compliance. And that is the organization, KBEC, is a statewide organization that is energy analysts, primarily Title 24 energy analysts. And they have a certification test that they have to go through to become a certified analyst. And the team has actually been looking at some of the results, and they've done a little bit of a study. It hasn't been published yet. They're still working on it, but it does appear that CEAs actually do produce higher quality documentation. And so from the jurisdiction's perspective, it might make sense to encourage that use. And basically the way that we do that is we reduce the margin a little bit. So they say, if you're going to use the CEA, you can achieve a slightly less margin, slightly lower margin. And the benefit there from the jurisdiction's perspective is that simplifies plan check, ensures that they get a more accurate model, and helps them go through the process a little bit better. And it's more likely that the project will actually be built as modeled that way. So there's a lot of advantages here. And I think that just about wraps it up for us. We have a little preview of a couple of things that are coming soon. As we've noted, we are updating this study. We're getting ready to, we're working on the report now, and that should be out in the next few weeks. We're also importing this data into our cost effectiveness explorer. We have been, Leah's team's been madly working on it so that we would have the data for you here today, but we do need a few days to get it into the explorer so that you can use it online. So I apologize that we weren't quite there, but it will be there for you very, very shortly. Okay, we are also updating our multifamily and non-res new construction studies, as well as our studies for existing buildings. And on the statewide code path, the 2025 code development is underway. And ooh, boy, do I have terrible lighting. I apologize. The sun just came in the window here. Apologies. And also wanted to note for folks that the Building Standards Commission actually, that did not help. I'm going to turn off my camera. That's just distracting. I apologize. The Building Standards Commission just adopted the intervening cycle requirements. There were many things included, but there are 3 pretty significant changes, and that is to the EV requirements. There are now embodied carbon requirements that are new, and there are some changes to the plumbing code where folks are allowed to use a different resource to size the plumbing, the pipes in single-family homes. The old resource produced way oversized pipes, and this one's a little bit more accurate, and so that's now been incorporated into the code. And I think that just about wraps it up for us. We are pretty much at the end of our time, but I believe, Aaliyah, do you have a few minutes? to hang on?
I do. Yeah.
Okay. If folks do want to hang on, if you'd like to hang on and ask a couple questions, we'd be happy to do that. We've got another 10 or 15 minutes if people would like to talk, but I really want to thank you, Aaliyah, for your presentation and for all the hard work getting this together for everybody and providing this information for us. And thank you all for making the time to attend. I really appreciate it. I know you're all busy, and we hope this is helpful for you in developing some new ordinances. So,
Absolutely.
thank you very much.
Thank you, Misty, and thanks everyone for joining. There is, there's no raised hands right now. There's a couple comments in the chat, and there's a question from Bronwyn about could this pathway be used as an alternative compliance pathway for certified passive house projects? And Bronwyn, yes, Misty discussed that at the, I can try and get back to it at the beginning of this presentation.
Yeah, it's like 5 or 6 way
about opportunities for using that as an alternative. So if there's one of the points Misty made was that please, if there's any jurisdictions that are interested in this, please reach out to us. And we think that there's some analysis that would be good to do to kind of vet this approach and establish equivalency. But we do feel confident that with all the benefits of a passive house, that equivalency is there and more. So thank you, Bronwyn, for being an advocate for passive house.
Indeed. It is a fabulous structure. Okay.
Bo,
you have a question. Yeah.
Thanks, Aaliyah. Yeah, one more thought, and that's about income-based rates. I know that we don't know where the rates are exactly going, but we do know that that proceeding is underway, and there is going to be a change where the electricity rates are going to be income-based. So a large portion of the rates that are currently by kilowatt hour are just going to become a fixed rate. So therefore, the kilowatt hour rate's going to go down. So it'd be nice if we could account for that in the escalation of the electricity rates. And if we don't do it in the main version, that would be best, but at least in a sensitivity analysis where you might take your escalation curve you have now and just step it down by X% starting, say, next year. And that could be up to like 50%, because I haven't looked at the proposals lately, but it's a pretty big jump where they want to take a big chunk out of the use-based rates and put it into fixed.
yeah, that's on our radar. And there's, like you said, it's being developed now. And as I understand it, the decision is expected mid next year. And so it's really hard to evaluate the impact of that rate without knowing a little bit more. We've talked through and seen some of the analysis that shows impacts going in various directions, in fact, different directions. And so, but we didn't get a chance to connect on this after the meeting a couple weeks back, and it still would be good to connect and get your thoughts and understand what you're thinking the impacts will be and how it might be able to be incorporated. Great. Any other
questions or comments?
Or raised hands?
I don't think so.
Okay.
All righty. Oh, wait, one more just popped up. Yes. There is the rates and rate structure driven by profit. So there are many different political considerations out there for sure. And as Aaliyah said, we've seen proposals that say it increases the rates or it decreases. We've seen them going both directions. So we're trying to wait for things to settle out a little bit so we know which ones to use. All righty. Well, thank you all very much again. Really appreciate you taking the time. Thank you, Aaliyah.
Bye, everyone.